Hi guys, in this video we're going to talk about limits and specifically limits of a function. So what I want you to think about is I want you to think about the function y is equal to x squared, or you can see here f of x maps onto x squared, f of x equal to x squared. That's just two other ways that we can actually write it. And what I want you to think is if I asked you just to put some numbers into here, then if I asked to put 3 in here for example, then you'd say okay, f of 3 is equal to 3 squared, which is 9. And that means that we get y is equal to 9. That's our answer. Now suppose that we get x get closer to the number 3. So the same sort of idea. And again, you see, we don't have to be too exact about this. We just want to imagine x is a number slightly above 3. For example, 3.0000001, or a number slightly below 3, 2.9999999. Take this first one. If I square 3.0000001, I'm going to be slightly above an answer of 9. If I do this one here, the 2.9999999, then I'm going to be slightly under the value of 9, which is what 3 squared actually is. Now, what we are doing here is we're saying common sense dictates that if I put 3 in here, what's going to happen is I'm going to get the answer of 9. But in some cases, what you'll see is that it will go towards a number, but it'll never actually get there. And that's what a limit is. So you can see here, we can write that the limit as x tends towards 3, that's the way we say it, of x squared, the answer is 9. And all we've done here is we've just put the number in and we've got an answer. Now we can't always do that, and we'll show you that in the next couple of slides. So our general definition of a limit is the limit as x heads towards a certain value of that function of x is heading to some limit which we call L. Okay, so for this one here, the limit as x tends towards 3 or heads towards 3 of the function x squared, we're expecting to get the answer of 9. Okay, there's a few rules here that we can see here, that if k is equal to a member of the real family, then the limit as x heads towards a is just k, because there is no x's in here. Okay, so nothing's going to happen. K is just a constant. If you take a limit of a constant, it's just a constant. If we have here k divided by 0, okay, and k is a member of the real family and k is not equal to 0, then there is no limit. The limit does not exist. Okay, think about it with the division by 0. If we have an infinity over k, again where k is a real number, it doesn't exist because infinity divided by k is something that mathematicians don't like to do. And if we have a constant divided by infinity, then the limit is 0. Again, if you think about k being the number of pizzas, so if I have k is equal to 2 pizzas, and I have 2 pizzas divided by an infinite number of people, then what's going to happen is I don't get much pizza, I essentially get 0 pizza. Okay, so the forms k over 0, infinity over k are called determinate forms. Okay, and it should be k over infinity there, as they allow us to determine whether or not the limit exists, and if it does not, or if it does, sorry, what it is. So let's have a look at this example here. So the first thing we have here is part I. It says calculate the limit as x tends towards 4 of x squared plus 3 over x minus 3. So lim as x tends towards 4 of x squared plus 3 over x minus 3. So the first thing we do when we try and work out a limit is just stick in whatever this value is for our x and see if it works. So let's do that. So it's going to be 4 squared plus 3 over 4 minus 3. So all I've done there is I put the x in, so 4 for all those x's. I'm going to work it out. Now the top one is 16 plus 3, so 16 plus 3 is 19. 19 divided by 1, so the limit here is 19. So that's there is the limit, not too difficult. For part 2, okay, we've got the same idea. We've got take the lim of 2x minus 1 over x squared plus x minus 12 as the lim x heads towards 3. So again, stick 3 in. You get 2 by 3 minus 1 over 3 squared plus 3 minus 12. Okay, let's work this out. So we've got 2 by 3, which is 6. 6 minus 1, which is 5. Okay, and then on the bottom, what we end up with is 3 squared, which is 9, plus 3, which is 12. 12 minus 12, which is 0. Now if you have a look here, what we have is we have a constant, which is 5 divided by 0. Now you can see here a constant divided by 0, that means that the limit doesn't exist. So therefore we can say the limit does not exist. Okay, so does not exist. Okay, sometimes what's going to happen is we're going to get indeterminate. If you remember last time we said that all the 4 rules that we had in the previous slide, then that's what we call determinate. We can determine whether there is a limit or not, and also what that limit is if it exists. However, sometimes we're going to get what's called an indeterminate form. And the indeterminate form is when we put in the number or our limit, and we put our limit in and we get 0 over 0 or infinity over infinity. Now for our course, guys, it's generally going to be the fact that we're going to get 0 over 0, and that means that we have to then try another technique in order to find the limit. Okay, so the way we normally do this is we look for common factor, numerator and denominator, and then we try and put the number through again. There's a graph here, and I'm going to show you how this works in a second. So you can see we've got x squared minus 4 over x minus 2 here. Okay, and this is the graph. And what you'll see here is if I put 2 in, and I'll show you in a second, we put 2 in here, we're going to get a division by 0, which means it doesn't exist here. It's indeterminate at this particular point, which is here. Okay, but you can see here that as x heads towards 2 here, you can see that the limit heads towards 4. It can never actually, because we can't have x is equal to 2. We can get very, very close to 2, i.e. 1.99999 or 2.00001. Hopefully you can see as we come from the 1.9, it's going to head towards 2. And as we come from the 2.0000, that's going to head towards 2 as well, even though it can't actually be 2. The limit there is going to be 2. Okay, so we're saying that as x heads towards 2, either from the left or the right, then what's going to happen is it's going to get very, very, very close to 4. It's going to tend towards 4. Okay, so let's just do the maths here. So we've got the lim as x heads off to 2, x squared minus 4 over x minus 2. If we put the numbers in, we get 2 squared minus 4 over 2 minus 2. And guys, hopefully you can see that's just 0 over 0. So that there now is indeterminate. This is here, indeterminate. Okay, we're not sure. We're going to have to try something else to see what's going to go on here. So what we do is we go back to the beginning. So we've got lim as x heads towards 2 of x squared minus 4 over x minus 2. Now hopefully you've spotted the top here is a difference of 2 squares. So we can factorize this, and we can factorize this to x plus 2 and x minus 2. Okay, difference of 2 squares, and that's still over x minus 2 on the bottom. Now I haven't taken the limit yet. Okay, all I've done is I've changed this form into this form here, and you can see here I've not put the 2 through yet. I'm going to put that through in a second. Okay, so if you get an indeterminate form, you go back, you see, can I factorize anything? Factorize it as much as you can, and now hopefully you'll spot there's some stuff that's going to cancel out. So this x minus 2 and this x minus 2 will cancel out. Yeah, divide both top and bottom by x minus 2, and they'll both become 1, which now means that we're left with the limit of x heading towards 2 of just x plus 2. Notice that I have not dropped the limit notation yet because I've still not taken a limit. I have just rearranged this and factorized out what I can. I can now put 2 in like I would normally do, and if I put 2 in, you can hopefully see that's equal to 2 plus 2, which is equal to 4. So the limit of this is 4. Now, as I said to you before, you can see on this diagram, as x heads towards 2, yeah, you can see here on this straight line, you can see that's heading towards 4, and this open dot means it can't ever be 4, because if we put 2 into, or it can't ever be 2 as well, if we put 2 into it as our x value, we get the 2 minus 2, which is division by 0, and we can't have that. Okay, so that's really, really important. It's tending towards the y value of 4, but it never actually reaches there. Okay, so let's look at another example. So what we have this time is that the limit of x heading or tending towards 2 of x squared plus x minus 6 over x squared minus x minus 2. So first thing we do is just stick 2 through. Okay, so let's have a look. We've got 2 squared plus 2 minus 6 all over 2 squared minus 2 minus 2. If we work them out, we get 2 squared, which is 4, 4 plus 2, which is 6, 6 take away 6, which is 0, and we have 2 squared, which is 4, 4 minus 2, which is 0, so that there is indeterminate. We do not know whether we have a limit for this or not. So the next thing we need to do is just see if we can factorize it. So let's have a look. We've got the lim as x maps onto 2 of x squared plus x minus 6 over x squared minus x minus 2. Now this here is a quadratic, so hopefully we'll be able to factorize this quadratic, just like the one on the bottom is another quadratic. So let's see if we can factorize these quadratics. So lim as x heads off to 2, the top one is going to be x, and it's going to be plus 3 minus 2. Okay, so if we factorize that top quadratic, that's what we're going to get. And the bottom, again, it should be 2 x's. Okay, x, and it's going to be minus 2 plus 1. So minus 2 plus 1. Just double check them. X by x is x squared, plus 3x minus 2x is x. And we've got 3 times minus 2 is minus 6. For the bottom one, x times x is x squared, minus 2x plus x is minus x, and minus 2 times 1 is plus 1. Now, guys, you are really expecting these to factorize in a question. So you can see I've got my x minus 2, my x minus 2 here. So let's sort that out. Boom, boom, change them for 1s. Okay, so dividing both top and bottom by x minus 2. And that now means that what we're left with is the limit as x heads off to 2 of x plus 3 over x plus 1. Okay, let's try it again, stick in the value, see what happens. And if we do that, we get 2 plus 3 over 2 plus 1 is equals to 5 over 3. So the limit of this original function is equal to 5/3. Okay, in this example, we can see here we have a surd. Okay, so the first thing I'm going to do is put 5 through, see if we can get a limit from just sticking the 5 through. If it doesn't work, then what we need to do is we multiply above and below by the surd conjugate, and then what we do is we go again. Okay, so check it, see if it works. If not, multiply by the surd conjugate, try it again. Okay, so let's put 5 through. This shouldn't be too difficult. So we can see 5 minus 5 is going to get 0 on the top. Okay, 2 times 5 is 10. 10 minus 1 is 9. The root of 9 is 3. 3 minus 3 is equal to 0. So we're going to end up with 0 over 0, which is obviously indeterminate. So let's have a look. We're going to start to try and sort this out. So the first thing then is lim as x heads off to 5. And what we're going to do is we're going to multiply both top and bottom by the conjugate. So what we end up with this is 2x minus 1 minus 3, which means we're going to multiply by the conjugate, which means we are going to change this sign here to a plus. Make sure you put it in a bracket. So what we're going to multiply by is root of 2x minus 1 plus 3, that's the conjugate, all over root 2x minus 1 plus 3, again, that's the conjugate on the bottom. Now, what I want you to do for this is to leave the top alone. So what I mean by that is if I just rewrite the top, it's lim as x heads off to 5. This is all factorised at the top, x minus 5. And what we end up with there is root 2x minus 1 plus 3. And what we're hoping for in this is that we'll get a common factor on the bottom. Now hopefully you can see this is the difference of 2 squares. If you can't, that's fine. What you can do is you can just multiply it out. And what you'll do with that, you get root 2x minus 1 times root 2x minus 1. That'll just give you 2x minus 1, the square roots will disappear. Okay, then the next one then is root 2x minus 1 times positive 3, so that's 3. I'll write it out. That's plus 3 lots of root 2x minus 1. The next one then is this minus 3 times this, which is minus 3 lots of 2x minus 1, the square root. And then the last one then is minus 3 times positive 3, which is minus 9. Okay, so that's what we have. Just going to make this a bit bigger here. Okay, hopefully you can see that that and that will cancel out. And we now end up with the lim as x tends towards 5 of x minus 5 root 2x minus 1 plus 3. And if we just get everything together on the bottom there, you can see it's 2x minus 1 minus 9 makes minus 10. And hopefully you can see we can actually factorise the bottom now, so you end up with lim as x heads off to 5 of x minus 5, bracket 2x minus 1, all square rooted, plus 3, all over 2 by x minus 5. And now notice that we've found a common factor. So that means we can now factor them out. And we end up with root 2x minus 1 plus 3 all over 2. Don't forget we still have the limit as x heads off to 5. Now what we can do, now that we've got rid of a common factor, is put 5 through again. Okay, and if we do that, we end up with the root of 2 by 5 minus 1 plus 3 all over 2. 2 by 5 is 10, 10 minus 1 is 9, root 9 is 3, so 3 plus 3, which is 6 over 2, and therefore the limit is equal to 3.